This is lesson 11, weather reports. So in previous lessons, we talked about weather factors that relate to soaring, including factors that make conditions favorable for soaring and other weather phenomenon that make soaring dangerous. In this lesson, we're going to talk about how you get that information so that you can recognize which category today fits into. We'll start by talking about the official aviation weather products that are available and where we get them. And then I'm going to talk about a number of other sources of information that are, some of which are more soaring specific, but they provide a lot of useful information that is more convenient than the official aviation weather products and has some information that isn't there. Finally, I'll talk about the procedure that I recommend that you go through as far as weather planning for a given flight. The first aviation weather product that you'll need to be familiar with is an aerodrome report. These are often referred to as METARs. These are observations of weather data at airports. So this is past data, but relatively recent. And these come by default in a highly coded format. A lot of sources like ForeFlight will decode these for you and present them in a more readable English language forecast or format. That's what I use in practice, is the decoded version. But when you are preparing for your knowledge exam, you need to spend some time looking at the coded versions and learning how to extract some information from them, because that's a thing you will be expected to do on your knowledge exam, is look at a coded forecast and be able to figure out some things. So each different line in the METAR starts with the word METAR. The second item is the identifier of the airport at which the observation was made. This third item indicates the time that the observation was made. The first two digits indicate the date. Like if it was July 30th, it would say 30. The rest of it is the hours and the minutes in Zulu time that the observation was made. So you can, if you know the current time, you can get a feel for how old this observation is. Occasionally the word auto will appear after the time. That means that was an automated weather observation as opposed to one where a human was involved. The next block of information is wind information, and that has a special format. The first two digits indicate the direction of the wind, or the first three digits rather. So 050 means that this wind is from the northeast. It's the magnetic direction that the wind is blowing from. Then there's two digits that indicate the wind speed. Occasionally you will have a G and two more digits. That indicates a gust amount. So like in this third example, the wind is coming from a direction of 150 at 15 knots, gusting to 20 knots. The next item in the list is the visibility, which is usually given in statute miles. Occasionally, when the visibility is less than a mile, they'll give you instead what's called a runway visual range, which is basically how far you can see down the runway. Anytime the visibility is less than a mile, you probably don't need to look much further. You're not going to be flying your glider that day anyway. The Next item after that is any weather phenomenon that happens to be happening right now. Like this BR and this first one stands for mist. There's a whole bunch of abbreviations. It's probably worth memorizing some of the more common ones, but there's also a page that you can find in the handout they give you when you take your knowledge test that has all of the descriptions of these. After that comes the cloud cover description, which you'll see abbreviations like OVC for an overcast. This OVC 007 means that there's an overcast cloud layer at 700 feet. BKN means a broken layer. SCT means a scattered cloud layer. Occasionally, you'll also see FEW for a few clouds at a certain height. So the digits afterwards tell you the altitude of the base of that layer in hundreds of feet. Occasionally on the knowledge exam, they'll combine testing your ability to read the METAR with your understanding of what constitutes a ceiling by asking you a question like, what is the ceiling at a certain airport? So scattered layers and few cloud layers don't count as a ceiling, but broken and overcast do. So like if they ask you the ceiling at KBRO, you would ignore these scattered layers and you'd say this overcast layer at 25,000 feet was the ceiling. So the answer would be 25,000. The next item after cloud cover is the temperature and the dew point. Those are just 2 digits each. That's in Celsius. And for a lot of things, we're concerned with what the difference between the two is. That's what will determine whether we have a risk of fog developing. Then we have an A with 4 digits afterwards. That's the altimeter setting. And then finally, there's a remarks section, which isn't always there, but when it is there, it begins with this RMK, and then there's a whole catalog of different abbreviations for different kind of things that can show up in a remarks section. A second type of weather product you need to be familiar with is area forecasts. Area forecasts are predictions rather than observations, and they're related to the region around an airport. Like METARs, there's a lot of sources that'll decode these for you, and the same advice applies as far as learning how to do it, how to do the decoding when you're studying for your practical exam. So the format for these starts with the location, which is an airport identifier, and then it tells you the time that the forecast was issued, which will be a time somewhere in the past, in the same format that of the time in the METAR. And then the next thing is the time period for which the forecast is valid. So that will have 4 digits / 4 digits, and in each 4-digit block, the first 2 indicate the date, and the second 2 indicate the hour. That's all is in Zulu time. The next block is the wind direction and velocity, same format as in the METAR. Then the visibility and any current phenomenon in the area, those are the same format as the METAR, and cloud cover, which is also the same format as the METAR. Then there's often some additional lines that get added to that information. Lines that start with FM and then a 4-digit code. These mean that at the time that's indicated by the 4 digits, the weather conditions are going to change to something different. And then basically you get a whole repeat of the stuff on the first line, telling you what it's forecast to change to at that time. A similar one is becoming, which is abbreviated with this BECMG. The difference there is that it says sometime um, in an interval of time after that it should change to the thing. They're not being so specific about what time that will change. There's also PROB and then 2 digits. That tells you that there's a probability of a certain amount, as indicated by the digits, that the weather will change to something different during that time. And occasionally you will see TMPO. That means that during a time interval that's covered by this forecast, there may be periods periods that are less than an hour long where some different conditions will happen. So a third type of product that you'll need to be familiar with is a pilot report. So these are observations, but they are made by aircraft in flight as opposed to being observations from the ground. And they are valuable for things that are hard to determine from the ground, like cloud height, turbulence, or icing. Pilot reports don't necessarily indicate bad conditions. In practice, pilots are more likely to file them in response to bad conditions than when they see that everything's good. These are coded just like the other products, and the code for decoding these, the first 2 characters here is either going to be a UA or a UUA. UUA means it's an urgent pilot report. The next section starts with OV, short for over. That indicates the location where the pilot report is related to. Sometimes it's just a single airport. Sometimes it's a route. Can be also like a distance from a navigation aid or something. TM is the time that the report was made. FL is the altitude at which the report was made, and FL is short for flight level. The flight level indicates the altitude instead of in feet, it's with the last couple digits of the altitude taken off. The TP is the type of aircraft. In this case, it's a BE-90, which is like a Beechcraft twin. That's important when we interpret some of this other information, like the amount of turbulence. If there's turbulence as reported by a Cessna 172 is going to be interpreted a little different than turbulence as reported by an airliner. SK is the sky condition. That's the same, that's these abbreviations like BKN for broken, OVC for overcast, and things like that. Sometimes the pilot report will tell you not just the base of the clouds, but the tops of the clouds, which is really missing from the other weather products. WV is the wind information, again with direction and magnitude. TB is turbulence, light, moderate, heavy, but take that, consider the type of aircraft reporting it. IC is icing, and then some others have additional remarks. The last weather product that I'm going to go over with you is the wind and temperature aloft forecast. And this is one you really do need to use when we're doing glider flying, because we need to know what the wind at higher altitudes is doing, so we know what direction we want to stay from our airport to make sure we are able to get back. So this is in a form of a table, and the rows of the table each represent a different location where the forecast is valid from. So we will look for an entry that is an airport relatively close to us to tell that's the one we want to look at. The columns of the table are at different altitudes, uh, increments of 3,000 feet up until we get up to 12,000 feet, and then somewhat bigger increments after that. Each entry in this table will generally have a 6-digit entry. So the first 2 digits in the entry indicate the wind direction. We need to add a 0, and then we get the magnetic direction of the wind at that altitude. The second 2 digits indicate the wind velocity in knots. And then the last 2 digits indicate the temperature in degrees centigrade. So up until 24,000 feet, the temperature will have a plus or a minus in front of it to indicate whether it's positive or negative temperature. Above 24,000 feet, the temperature is always going to be a negative number. It's always below freezing that high. Some entries may omit some of the information, the lower entries in particular, like this 4-digit thing here. These we don't have temperature data at 9,000 feet for ALS, and like for Denver, we don't have information at 3,000 feet and 6,000 feet because the field elevation at Denver is high enough that that isn't actually up very far. So where do we get these official weather reports? One of the most convenient ways is to go to a website called aviationweather.gov. We can also get them by telephone by calling 1-800-WX-BRIEF. Obviously, they will decode the products for you, and you call and get a briefing from there. When we get the briefing that way, it goes on record that we've called and gotten a weather briefing, which would be valuable if you get involved in an incident and the FAA wants some proof that you got a weather briefing. Also, tools like ForeFlight are a good place to get these weather products, and they will decode them for you. There are a lot of other places that we can get weather information that is specific to soaring or just more convenient than the official products. One that I use routinely is SkySight, and I've got a number of slides coming up talking about some of the information you can get from SkySight. This is a paid service. You need to make an account. It's pretty affordable, however. There's a website called Windy. I know a lot of people in the club like to use that to get weather. There's another free site called Dr. Jack that other people have used. I've got a couple slides about a skew T chart and how to interpret those and use that to get good information. Those are available from a government website called Ruck Soundings. There's also a lot of weather information at this website called weather.us. which that includes the K index and the lifted index that we discussed in the severe weather lesson. Forecast.weather.gov is a good source, and I've set up a link to that on my phone to get a nice presentation of weather data on my phone whenever I want to look at it. So let's start with some of the stuff we can get at aviationweather.com. One of the good charts is these surface analysis or prog charts. These cover the next 7 days. The next 2 days, they give it to you more than once per day. The when it's current information, it's called a surface analysis chart. When it's a projection of the future, it's called a prognosis chart or prog chart. These show things like fronts and areas where precipitation is expected. They also show, highs and lows and these lines that are areas of constant pressure, called isobars. The wind will generally be parallel to the isobars, going clockwise around high pressure zones and counterclockwise around low pressure zones. So you can get a feel for wind direction from that information. So there's a chart on the aviation weather website called the Aviation Forecast Chart, which is a configurable chart. You can configure it to show different pieces of information. If you tried to show everything, it would be too packed and you wouldn't be able to figure out what's what. I find it to be a good chart for surface winds. These various symbols indicate other concerns that are worth looking at. And this chart covers the next 18 hours in 3-hour increments. So it's a good day ahead kind of planning chart. There's also a chart for SIGMETs and AIRMETs, which are advisories that are issued for adverse aviation weather, things like poor visibility, icing, turbulence, or thunderstorms. You can get a graph that shows any areas that are covered by a SIGMET or an AIRMET, and if there is one covering an area that you're planning to fly in, you can click on it and get more information about what type of adverse weather is forecast for that area. Okay, moving on now to SkySight. This is the paid service that I like to use for deciding whether or not soaring is a good idea on a given day. I got it configured here to show thermal strength as my default view. There's a lot of different pieces of information you can choose to show. This is color coded by what strength of thermals are expected in different areas. So when you see better thermals in another area, maybe that would be if you're planning a cross-country flight, you might want to choose that area. If they're better on a different day, you might want to choose to go soaring on a different day. This dots indicates that the thermals tend to be kind of broken up. So even though there may be thermals that are strong enough to climb in, it will be difficult in those areas to work those thermals. Another chart that's really useful is this graph of the height of the thermals. So you can get an idea of how high you should expect to be able to climb in thermals on that at that time. Notice that along the top you can page forward and backwards to look at different days. This goes ahead like 5 or 6 days. And you can also use this slider to look at different times of day and get a feel for when would be a good time to go. So those charts were for areas at a particular time. Another way to look at the forecast is to pick a particular place and look at how conditions will change over a period of time. So to do that, you go to SkySight's point forecast, and that will show you for a given day, over the course of the day, things like what kind of clouds to expect, thermal strength. So here we see that the thermals will be strongest kind of between 1:30 and 2:30, but reasonably strong starting from noon and going until late afternoon. The soarable height gets progressively better up until late afternoon. This condensation level is kind of showing you what level the clouds will be at. And things like wind gusts and wind gusts are useful to look at. So this is good for kind of planning your day, deciding what time would be best time to take your soaring flight. So a skew T chart helps us determine what's going on in the atmosphere, or what's predicted to be going on in the atmosphere at a particular place at a particular time as a function of altitude. So this blue line is the dew point as a function of altitude, and the red line is the temperature as a function of altitude. And the scale for those two things is, the temperature scale is skewed diagonally, and the pressure scale uses a logarithmic chart. The effect of that is to make the line kind of vertical for temperature as a function of altitude. The right-hand side of the chart, there's often going to be these wind barbs as a function of altitude that help you see at kind of a glance what the wind will be at different heights. So the usefulness of this is when the temperature line is slanted over a lot, that tends to indicate a high temperature lapse rate with altitude, which means unstable air and good chance of thermals. When the temperature line is more vertical, or actually slanted a little bit to the right, then the temperature lapse rate will not will be pretty stable, and you're not likely to get thermals. And when the temperature goes less than the dew point, that's when you'll expect clouds to happen. So at the Ruck Soundings website, it's actually an interactive website. So I've blown up the chart a little bit here to show what information you can get from this website. If you move your cursor around, you can indicate the temperature and at the ground level, and then the chart will add this pink line, and the pink line is an indication of if a volume of air from the surface that was at that temperature you indicated were to rise through the air, what temperature it would have at different altitudes based on the adiabatic expansion of air. It uses the dry adiabatic expansion up until it gets to a point where condensation would start to happen. So when there's a good space between the temperature line and the red line and the pink line, the more space, the better the thermals will be. this line where they cross, that's kind of the where you should expect thermals to stop. And you can hover over that and read the altitude, or look over here at this chart on the right. So now let's talk about the procedures you should use and when you should look at some of these different pieces of available information. So I like to start looking at the weather up to a week ahead of a day when I have an opportunity to fly. That's especially true if I have some flexibility and I could choose, gee, am I going to go on Friday or Saturday or Sunday? And I want to choose the day with the best weather. So when I'm looking, a week ahead, I look at the prog charts. I also like to look at SkySight. That predicts out about a week ahead, and start picking which day I think would be a good day to go. When we get closer, the evening before, say, then you start looking at more uh, current information. I still look at the prog charts, but I start looking at the area forecast, the aviation forecast, and starting to look more detailed at the at SkySight. That's when I start to think more in terms of, gee, what time of day would be the best, and if I do plan to go soaring, which direction would I go to find good good soaring conditions. So on the day that you're planning to fly, it's good to recheck the stuff that you looked at the night before. Also start looking at the weather observation for airports in the region. That'll give you a lot more information about what is actually happening with the winds and the temperatures, as opposed to just what was forecast to have happened. And getting an official briefing from a flight service station. You can call 1-800-WX-BRIEF, or you can sign up and make an account, and then you can get an official briefing electronically from the website.